Sorry, 1 minute. Okay, so like I said, we had a bit of reshuffling. So before we take the presentation, so we're going to be taking Mr. Emeka's masterclass shortly, so that we can quickly just see what that's about, and we can go into every other side of the event. So I don't think I need to do this again, or do you want me to start? So we all know Mr. Emeka, right? So let's just give it on to him. Yes, sir.
Thank you. Okay, good morning, everyone, once again. So I'm here to give an overview of large language models, knowledge graph, and retrieval augmented generation. This is not going too deep because this is just to just for us to have a feel what's going on. I think the notice was too short to do something very deep. So we're going to, I think I have like 60 slides here and like 30 minutes to go. All right, so this is me. I work at a land governance organization called Landport. They are based in Netherlands. They have one of the largest repository of land governance data. Everything about land, land conflicts, land rights, land tenure, women, ownership and all that. We are building one of the biggest knowledge graph in the world. So our agenda, I'm going to an introduction. I'll talk about generative AI, language models, knowledge graph, AI, and retrieval augmented generation. Okay, so I'm going to start by talking about my work, okay, so that we get to understand that there are some things between data science and AI, which is knowledge representation. So my work basically is to help, institutions. Some of you might know that, the richest, the most popular city in the world are running on data. So, the job opportunity for folks in data is quite a lot. So, undergoing digital transformation. Digital transformation is our objective of trying to be data-driven, trying to be fully online, fully automated, and all that. Towards data-driven, sorry, go back. Yeah, so towards data-driven operations to exploit their data and information assets. So institutions have data and information assets. This is the first thing we should have before being able to use data. You must have data and information assets. And then, in capturing information and knowledge. No. Capturing information knowledge needed to simulate human decision making, okay, and high-level cognitive tasks that can be used to solve complex problems and achieve their business objectives. So everything that you see here, everything that you see here is captured in the data pyramid. Right? Data, information, knowledge, and decisions. Okay? Everything is captured in the data pyramid. Next one. All right. So this is the raw data set. You guys have seen the data pyramid, right? Oh, you need this if you want to. This is important. So you have your raw data. So everything is aggregated. This is where the data engineers operate. Right here, right? So you have, when they are linked, categorized, the data starts becoming smarter. That's when you now start turning data into information. Then, you start adding more tools and being able to do some analytics before deriving some actionable information. Actionable information are those knowledge that makes you act, do something or don't do anything. It's when you don't do anything, it's actually actionable. So this is the data pyramid actually. So data, information, knowledge, and wisdom. Okay. So this, everybody, if you are in data, you need to know this. Go and read it all. Just type data pyramid on the DIKW pyramid, everything about it. It's key that we understand number 3 because it's process data with context. Context is probably one of the most powerful things when it comes to deriving knowledge from data. So we're going to talk about that context soon. Next. Okay, so for those who have been to my masterclass bootcamp, so this is one of the first images. So there are 2 approaches to building AI. You need to know this, even if you are not in knowledge representation, which is semantic reasoning. Okay, so why you need to know this is because what you're going to learn is actually because of this. So machine learning helps machines to learn from experiences which are embedded in data. You all know that. But in knowledge representation, we teach machines what they need to know. Okay, this first line is what we are going to use as the retrieval augmented generation. Now, all other ones just to differentiate domain knowledge, semantic usually has domain knowledge. They rely on knowledge models. Yeah, everybody claims that knowledge representation is hard. That's what they said, but that's where I am. Machine learning, they say it's easy, but I think it's hard. And, so, but all those things are next. I mean, those things are clear, but it's just the first one that I really wanted everybody to understand. Helping machines learn and teaching machines, those 2 key things is what I'm going to talk about. Okay, so knowledge, again, very key that people understand knowledge. Knowledge is what makes people intelligent. Knowledge is what makes machines intelligent. Knowledge, we need to understand that because we are talking about artificial intelligence, right? Now, this I will show it on all my presentation. So DSN, I showed this on DSN bootcamp twice. It's just to show that we actually knew this was going to happen. Rule-based systems, which are knowledge representation systems, you can see they have weaknesses, strengths and weaknesses. So they can perceive, but they can't learn. They can't abstract, but they can reason. Machine learning can perceive, can learn. Abstracting is poor, reasoning is poor. But this is what we need. Combining both, best of both worlds. That's AI. Here, and everything improves. Best of both worlds. Now, look at approaches of artificial intelligence. Knowledge approach, machine learning, leading to intelligence of machines. Okay? That's what it has always been, but we're in a hurry. to make it one-sided. Now that's why now the AI race is just about starting. All right, so this is a Gartner list on the Gartner hype chart on generative AI. So just to show you guys how things are moving, you will see here a lot of things I'm sure you are familiar with. Let's start from, AI orchestration just started. Orchestration and automation, responsible AI, generative AI, AI governance, human-centered AI, synthetic data now that, GPT is generating a lot of synthetic data, decision intelligence, transformers, smart robots, knowledge graphs. So we are now moving from innovation trigger, hitting that peak of inflated expectations. And then we'll come down to the trough of distribution, you understand? When, we should be getting some disappointments first. Those that survive this will now become, we can see now that computer vision is now maturing and it's now getting to a point where it's going to be useful. But we expect most of these things to successfully go. Now, this is the AI maturity index. So, we start here, the point of hype moves up to experimentation in data science. Then we start producing value, via innovation. And then, we passively use for digital process and transformation. So this is where digital transformation in organizations matter. Organizations that don't have digital transformation won't, achieve this. This is why I say, if our governments don't have this, we're all joking. Nothing, you are not going to solve the water problem in your state if your government is not, available. And then AI is part of the business journey. So these are, generating opportunities in the industries. So you could see like pharmaceutical drug design. One of the things that made COVID vaccines, quickly they came up with vaccines is open data and knowledge graph. Okay, so the combination, some of the things we're going to talk about are the things that hasten, design of vaccines and drugs. In material science, it's actually one of the biggest surprises because it's going to affect things in the material science. So we're talking of iron and steel, materials used to build. And then synthetic data for virtually every industry as well. Generative AI is going to, go in those places. Now, these are the top strategic technology trends like that now for 2022. We see data fabric. Do you guys know what data fabric is? Okay. So we have privacy enhancing computation, composable application, decision intelligence, AI engineering, and generative AI. So, just to tell you how data and data science, knowledge engineering is. So we'll start with generative AI, which I'm sure you guys know. Right. So it's a sophisticated branch of AI that enables machines to generate, new content, be it video, audio, code, whatever. That's the era we are right now. Okay. So it learns the patterns and structure of their input training data, and then generate new data that have similar characteristics. Gartner lists as one of the most impactful, evolving technology that can bring productivity, revolution. So we already see that in coding, in generating, even generating knowledge. The contents are it's generating a lot of content, which might even affect big data because it's creating additional data on top of big data that has been generated by all. So there's huge data coming in, you know. One of the most prominent examples of generative AI and GPT, which you all guys know, blah, blah, blah. I'm sorry, you guys know this. Next one. You know, so it's just for us to, you know, just get a simple feel of what's going on. So we know what the language models do, you know, and this is where the problem starts, you know, because this prediction here is not based on knowledge. Okay, so remember I mentioned about knowledge being, you know, foundation of intelligence. It's not. So it does this, you know, via probability and statistics, whatever algorithm it does, but it doesn't come with, it doesn't know what I'm about to say. It doesn't. You know, what gives me the most likely next word. Okay? It's a good thing if for us from the knowledge representation, the hallucination is not so much a bad thing because we don't expect it to get it right. It's when you expect it to get it right, that's when it gets a problem. So we see it as it's suggesting, you know, suggesting something new. You understand? When we think that this is what it is, it's when it's a problem. So these are things that, you know, we are going to address in the future. Right. So language models, you know, are trained to understand and generate human language, learn the statistical structural patterns of language from large amounts of text data. These models can perform tasks like they perform mostly natural language processing tasks. Okay. Yeah, so prominent models are GPT-3, blah, blah, blah. All right, so knowledge graph. So a knowledge graph, now let's spend some time here, because this is what a lot not used to. So why is knowledge graph so special? You know, I've been doing knowledge graph for the past, maybe 12 years. So we've been using knowledge graph. You know, it's a special kind of database. You know, so knowledge graph is a structured representation of information that captures relationships between entities in a special domain, relationships. You know, when you have your data model with machine learning, you don't talk about the relationship between the variables. Relationship. Here in knowledge representation, relationships are first class things. So everything is about the relationship. We emphasize so much about the relationship. That relationship leads to a tight engagement, interaction, lock. Okay? If you can understand that to mean that it brings up relationship between two things together, they're establishing that relationship. We're not establishing it with probability of statistics. We're establishing it with a relationship. See the difference? You can now start seeing clearly the difference is now showing up. Again, let's go back to that frame about machine learning and semantic reasoning. Remember, one learns, then the other one teaches. Okay. If you understand this, you will be big. This knowledge, a lot of people don't get it. One learns from data, the other human teaches it. Okay? Okay. And which one would you do? The one the human teaches. Yeah. So that's why we use the one the human teaches to correct the one that it generates. This is how we are solving the problem, the weaknesses of language model. If you can explain this, you see, then you can now understand when this is beyond your domain, you push it to who will fix it. That is what is going on today. So knowledge, so you find out that it consists of entities and edges, which are relationships that connect those entities. So knowledge graph are used to represent and organize data in a way that's more easily understandable by both humans and machines. So they are commonly used for semantic search, data integration, and information retrieval. So the fact, knowledge graph actually represents the way your brain and your mind works. You know, how we see things, because everything is related to something. Everything in the world, everything is related to something. There's nothing that is on its own. I can establish that this bottle of water relates to my village. Most likely one of the raw materials came from my village. So that it establishes a relationship. So that's how we see the world. Everything is related to something. You know? So in order to have entities that are represented as nodes and relationships between them as edges. So Leonardo da Vinci was born in Italy. So Leonardo da Vinci and Italy are connected. He's born. That's the relationship. If we didn't have the born in, we wouldn't know that there's a relationship between them. Okay, we all know that name. But beside that name, just the same way I'm telling you now, that there's a relationship between this bottle and my village. A raw material will establish that. So, how do you want your language models to know that the next word they're going to predict is compared to the last word that you typed? Yeah. Okay, so so this is how semantic tables, this is how we represent knowledge. You know, the same way we talked about Leonardo da Vinci. It's basically subject, predicate, object. Now, if you understand language, any linguistic person here. Okay. So this is how languages are done. This is linguistics. No difference. You know, this is the course in linguistics called matrix. What's it called? The matrix. Yeah. So this is it. So this is how we represent knowledge. You know, in this form. We're going to come back to this. Next one. Yeah. So this is the knowledge graph. So we have the. So this is how we now our data. So this is how the data in knowledge representation looks like. So we have different content sources. So let's say those sources that you download, you get your data sets for your models are here. Okay, but here is the thing, because we now wanted to add more context. Now I mentioned that context is the most important thing when it comes to data. Context. So number one. So what are the terms? If you understand linguistics, you understand that language is used to communicate intelligence. We use it to communicate intelligence. We use it to communicate knowledge. Okay? So when I say come here, yeah, it's an action word. Come here, you know what it is because it means you should come, right? So we need to use a term that is acceptable to a group of people or a group of machines. So that's what we do. Oh, sorry, go back. Yeah, so that's what the taxonomy is. Okay, now we apply that taxonomy to what we call the ontology. So the ontology is like a map, a specification. So, like, my brother here is a man. He has 2 eyes, 2 ears, 2 hands, right? So that's the specification. Okay, so that's an ontology. So when we see and when we classify that specification as a man, anytime he sees a man, we know that he has 2 eyes, 2 whatever. Okay. So that's what ontology is. So here we define any concept. So anything that lives. This is this is psychology. This is philosophy. Sorry. So we've talked about linguistics. This is linguistics. This is philosophy. Things that exist. So this is how we define things that exist. Everything that exists can be described. So we describe them with ontology. All this will now create into what enters knowledge graph. I'm emphasizing this to tell you how rich the data in the knowledge graph is. Look at it again. The terms. Look at it is relationship of the terms. So look at that word, educational intervention. So unlike you have mathematics reading study, right? It's a relationship, hierarchy. Yes. So it means something when you see words in two different categories. So there's a relationship. So I'm telling you that in knowledge graph, relationship is first class citizen. So it's about the relationship. So when you see something that is on another category, it tells you something. So when you have that with a specification, you use to describe everything in the world. Everything. You can describe microphone, furniture, yes, as a concept. Furniture could be anything built with wood, something like that. You set it up as an ontology. Then you have your graph data, which is linguistic description of knowledge. All this we apply into the knowledge graph. So the data here is rich. It's a rich source of data. Those plain data sets is a rich form of data that describes a domain. So a domain can be a topic, a category, a class, something. Domains can be city, it can be water, it can be tomatoes, it can be jollof rice. Yes, anything can be a domain. Okay. So now these are how knowledge representation describe, text. U.S. government belong to Louisiana. These are just how we extract entities from text and their relationship, their connections. Okay, connections, relationships, very. So before you move, so I have just shown language numbers, which you all know. And I've just shown knowledge graph. One thing you can pick up from knowledge graph is, it comes with rich data of domains. A lot goes into that data. Okay, so they're not plain data that you just get download from site living on this phone. No, relationship matters. Okay, and if you look at how explicit the relationships are, you find out that it's hard, not that it's impossible, it's hard to create fake data. So it seems to be related to something in the real world. That's the thing about the knowledge graph. So that's why in AI, under artificial intelligence, is very important. Okay. So now look at our situations. So we have the LLM, then we have knowledge graphs now. Users are able to ask their own questions, right? On LLMs and even on knowledge graph. So any database that is pretty useless, unless the user can ask, any database is pretty useless unless the user can ask and get answers to their questions. So if you have a database that people cannot ask questions, then it's useless. Very key, because data being there doesn't mean anything, right? Okay. Knowledge graphs are superb at representing the domain's data together with a model, can deliver answers through the question, but it needs to be formulated by an expert. We use a query called Sparkle. That's a query we use for knowledge graph. So it can only be used by experts to ask a knowledge graph question. Then LLMs allow any user to ask a question to retrieve a comprehensive answer, but that answer will not include information drawn from the user domain data or the real domain data. Okay? Because when you're asking questions, most times you're not asking a general question, you're asking towards a particular domain, you know. So that's the challenge. Knowledge graph can prompt or fine-tune an LLM, enabling users to ask their questions on the data that they want. Fine-tune. Now we are now getting towards mixing both of them. So AI is actually knowledge graph and LLM. The same thing about knowledge representation and machine learning. So answering open domain questions requires world knowledge about in-context entities. So that's what you get from knowledge graphs. As pre-trained language models lack the power to store all required knowledge, external knowledge sources, such as knowledge graphs, are often used to augment language models. Yeah, so that's why you now keep seeing a lot of language models, knowledge graph, knowledge, you now see a lot of articles coming up. In fact, the articles started coming out, I think, from January, February. Okay? So, this collaboration that is happening, knowledge graph can improve LLM. It can empower language models with knowledge graph reasoning. So one of the things knowledge graph does is what they call semantic reasoning. Reasoning is when you infer, then you come to a conclusion. So that's reasoning. Okay? So you infer facts. So you can create facts out of existing facts. It's logic. This is now logic. So that's one thing we do with reasoning. Okay? Do you guys understand logic? Huh? Okay, because you can't talk of intelligence without logic. Yeah. So that knowledge graph does that. So it can give that ability to language models. Okay. Then a knowledge graph can provide context to language models by incorporating information from the graph, and they can better understand the relationship between different entities and contexts. So therefore, making accurate predictions about the meaning of a given text. Yeah. So now you can use knowledge graphs relationship strength, and empower language models, and it will reduce hallucination. It's already reducing. Because now it's not by those texts that you need to train them that we got from the wild. From the wild, that's the World Wide Web. It's the wild, right? Good. So, and then another graph can help to disambiguate words and phrases. Now that's, for instance, there's some Berlin. Okay, so Berlin is a popular city in Germany. Yeah, but Berlin is also a district in somewhere in America. So how can you know which Berlin I'm interested in? Is it the district? Yeah, or yes. Or when I say bank, which bank do you think I'm talking about? Is it Bank of River Niger or Bank of Zenith Bank? Is it now getting clear? Good. Context, remember, context. So another graph can help fill in the gaps in the language model's knowledge, no doubt. So if the language model encounters a rare or specialized term that is not familiar with, we can use the knowledge graph to look up additional information about the term and incorporate it into its understanding. So yes, it would a term that it doesn't know. So rather than hallucinating, there's somebody that does talks, Let it at least make an attempt to find out what it doesn't know. Okay? That's the thing. Okay. LLM is going to tune to your domain's information. We have seen that generic knowledge corpus can be supplemented by providing context information about the domain. However, this is very limited insight. So this is where we are fine-tuning language models. Okay. So it can be fine-tuned with an unlimited amount of training data at a cost. So depending on how you're going to train that, but training data needs to be gathered, cleanly prepared for training. Preparation of the data for fine-tuning involves supplying a series of prompts and their corresponding completions. Okay, so we have this. So let's keep it here for some time, but this is one of your takeaways. Okay, so I'm sure you guys know what this thing is. Who has fine-tuned a language model there? No. Some people try. All right. No worries, that's just that. Okay. Oh no. I said we are still here. We're going to... Okay. So this is the format we use to train language models. Okay, the prompt and then the completion. Yeah, the cat sat on the mat. Okay, so that when somebody types that, it comes. So that's pretty standard. But from that Reboiler 601, let me explain that that's graph is what we call a graph statement. So that semantic graph. So Reboiler 601, this came out from the pipe. So description of pipe. Just before I go further, let me just tell you, this came out from the digital twin. One thing that I haven't mentioned is that knowledge graphs are automatically digital twin. They are a reflection of a real life, real world thing. That's what knowledge graph is. So by default, it's a digital twin. So we have here a pipe. So this is from a construction knowledge graph, a pipeline knowledge graph. So Reboiler 601, that's the name of that pipe. Is connected to pipe 005, is connected to pipe 006, and then it's connected to pipe 012. So that's how it comes out in the graph. All right. Okay, so we have this now. So we know what Reboiler 601. Okay, so if a question is asked, what is Reboiler 601 connected to? We can now establish that relationship in the knowledge graph. Listen, this is what everybody is now doing. So we have to take this serious. So the relationship we establish in the knowledge graph, we can now use it in our prompt. So the question so we can choose questions for those pipes and then use it to create our fine-tuning prompts using from knowledge graph. So you have a rich data set that you can use to fine-tune the knowledge graph. So there's a chance that there's no hallucination if you ask questions about, concerning those pipes. So it's there. The good news is that 3 or 4 lines of jump code can generate this automatically from the knowledge graph. It's not that hard. It's as simple as you're looking at it. In fact, if you give me meat pie, by the time I finish it, you would have learned how to write this. Yes. So I hope it's clear. Yeah, it's getting clear, right? You've learned something new. Good. Now, there are many further ways of fine-tuning a language model with a knowledge graph. So fine-tuning could use serialized statements combined with concise bound description. Indexing could use see, whichever ways you can fine-tune your language models, knowledge graph data, rich data set is the best and ultimate choice to use to fine-tune your language models to reduce hallucination and improve its knowledge. Okay, so let's turn the relationship the other way around. Because knowledge graph, like I emphasized before, knowledge graph has its own weakness, especially the prompt. The prompt is meant for only experts, so that's not good enough. So language models can be used to enhance knowledge graph by extracting information from unstructured text and populating the graph with new data points. So let me talk about this, because this is what I do when I'm working. It might not be good news for some of you. So ChatGPT is my new data engineer. Yeah. So I give you commands. It creates pipelines. It brings the data, ingests it from inside into the knowledge graph. So I don't need humans. So as much as I'm telling you that there are plenty of jobs, I'm also telling you that the jobs are also interesting because of ChatGPT. Yeah. But it's not, don't worry, it's not all that bad. The only thing is this: as more jobs are being created, less of these data engineers will be used at location. So where we are supposed to use like 5 data engineers, we go to probably like 2. Then all you need is 1 license of ChatGPT, and you can overuse it. Yes. So it does that. So I give you the text, I give you the ontology, and it generates this thing. In fact, there's a tool, my former company, OpenLink Software. So they have a plugin called Sparkle plugin on the plugin data storage for OpenAI. So that Sparkle takes in the generated code and automatically pushes it into the knowledge graph. You understand? It's quite amazing. So that's how the language models can help extract information to complete their life. The language models can construct knowledge graph from pre-trained language models without human supervision. Yeah. So it just tell you, as much as we are creating more jobs, some jobs will be destroyed. Yeah, popular knowledge graphs like Wikidata are built in either supervised or semi-supervised manner, requiring humans to create. But to be honest, I prefer the semi-supervised manner. Human input is very important. I can't trust these machines, before they have the mind of their own and start putting data into your graph. So let's not do that automation one, because I've used it and it didn't turn out well. Better than supervised. So yeah. So recent deep learning models automatically acquire knowledge from large-scale corpora. They are pre-trained. The stored knowledge has enabled the language models to improve downstream NLP tasks, like answering questions, writing code, and all that. So yes, it does. Give it help sometimes. It does help in improving generation of graphs, from unstructured source. And you should know that 92% of data in the world are unstructured. So and unstructured data is what's called data engineers and some data scientists work. So GPT is now automating these things. easy to automate. Now we are here. This is where the retrieval augmented generation starts. So this is the command. This is the framework. Okay, how we can, this is a language model, but we have the challenge that the language model might not have all the information. Might not have all the information. So we need to get external knowledge sources. So this is where we can build knowledge graph, bring your office data, so that they can use that data as part of what is sent to the language model, so that they will improve the answer. Actually, anyway, let me move towards the end of that. Okay, so this is basically, you have the indexer and the retriever. That's basically what the architecture is all about. Okay, and that generator is the language model. So that's basically the structure. So retrieval augmented generation is a sophisticated approach that combines the strength of retrieval-based model with sequence-to-sequence generation. So it's a type of language generation that combines retrained parametric and non-parametric memory of language generation. So it introduces an intermediate step that involves retrieving relevant document before generating a response. Does anyone see anything familiar with what I've just said? Maybe think about it. The first person that figures it out is her. So it creates an intermediary step. That's something that you need to understand. So that it takes data from somewhere else. So we already have the trained language model. And then it takes data, maybe from the knowledge graph, from the office data and all that, as part of its response. So retrieval augmented generation is a feature that enables an LLM to utilize your own data for generating responses. Okay. So we are now trying to solve the challenges of language models. So it also means the model first retrieves relevant documents from the lab. Yeah, okay. From a large corpus of data and use them as context. Context. Again, context matters. So we need for us to be clear what kind of information response will be expected. Context matters. The most powerful thing about knowledge graphs is that they have context. So for example, if you ask the model a question about historical event, you first search for documents that contain information about that event, and then use them to produce an answer based on the facts and details from the documents. So this way, the model can leverage external knowledge that's not encoded in its parameters and generate a more accurate, informative response. Nobody has noticed anything yet. So it's based on this paper by Patrick Lewis and co. Retrieval augmented generation for knowledge intensive NLP data. Okay. Do you guys read a lot of papers? Like how many do you read in a week? Oh, yeah. You should also make that a habit. If you can say, for instance, I'll read 3 papers a week. Okay. 1, 5, 10, 20, just make it a habit. Okay. All right. So this is but let me read something from the abstract of it. So large pre-trained, it's obvious. Large pre-trained language models are shown to store factual knowledge in their parameters and achieve state-of-the-art results when fine-tuned on downstream element intact. However, the ability to accept and precisely manipulate knowledge is still limited. So we've emphasized that. Okay, and hence, on knowledge-intensive tasks, their performance lags behind task-specific architecture. Additionally, providing provenance for their decision and updating their world knowledge to remain an open research problem. So this was after this paper was 2019 or so, I can't remember. Okay, so that's why right now we are coming with solution. Okay, that's again why I'm saying, you know, make sure you read paper so that you keep yourself updated. So there are two main components in the RAG: retrieval and then generation. Okay, so remember the RAG and you know, between prompt and response. Okay, so this retrieval, the component focuses on retrieving relevant info or context from a large database or external source. So it can involve statutory documents, articles, text-based data to gather info that will help in generating high-quality text. Okay, so now the generation, once this relevant info has been retrieved, the generation component takes over, utilizing the retrieved context to generate coherent, contextually relevant text. The text generation can range from completing sentences to or paragraphs to even creating entire documents. So you see that we have now shown from a rich set of data sets, we can create concepts that will aid in improving the answers that comes from this pre-trained model. And it becomes relevant because you want to use it to work in your organization, institutions, you know, and all that. So that's why we need to make sure that external data. You know, your GPT 3.5 is September 2022 or so. I'm not sure. Okay. So what happens to that data that we just collected yesterday? Are you saying that ChatGPT cannot make use of that data? No, it has to. That's why we need a RAG. So with the RAG, I can put in all the data that we are collecting, you know, as part of it. You guys haven't still noticed anything. I think I've said it 3 times. So I'm just waiting for which sharp enough to recognize something. Yeah, what? You recognize something? What? Eh? No. No. It's one word. No, it's no. I don't want to say no, it's not one word. If I say it, you guys might get it. Well, don't worry, if you don't get it, I'll tell you. But just keep. Yeah, so that's it. So next one. So now, so these are frameworks. Okay. I don't know how many they are, but these are the ones I've used. I use Llama Index a lot. I don't know if you use this. Okay, but you guys know it, you've seen it. Oh, you have the course. Okay, you have the top grades. It makes life easy. Okay, so yeah, okay, so but you couldn't connect it to these problems. Yeah, so fine. So we have Llama Index, LangChain, Council, they just came out. Yeah, my friends. I have to state my bias. So basically, okay, so since you guys have it, there's not much to say, or you want me to go through it. You did the course, did you run the software? Did you set up the software? Okay, so basically that's what there's nothing, just go through it. Yeah, I don't think there's anything I can tell you that is different. Oh, okay. All right. All right. So it's a data framework for creating language model-based applications. So, applications, working on that RAG framework. So, Llama Index first ingest data from APIs, databases, PDFs, and more through their data connectors. So this data is indexed into intermediate representation, then optimized for the language models, then allows natural language query and conversation with your data via query engines, chat interfaces, language model powered data engines, which enables your language models to access and interpret private data on large scale. Now, let me emphasize that, we have issues about language models can change. We have issues on language models accessing private data. So we have to be very careful because that part is not clear. The data that you have might be used. Some people will swear by their native doctor that they're not taking doctor. You trust their native doctor, then no problem. If you don't trust, you're on your own. You can bring your native doctor to come and inspect the system. But it does people be careful and make sure that data governance is good. Okay. So Llama Index uses the RAG systems combination of language models with private data or private knowledge. So you have the indexing stage, which Llama Index will index your data, either a vector, mostly a vector store, and uses a lot of vector storage. I use Chroma. You guys know what Chroma is? Okay, Chroma is, I think it's high time you guys pay for this course. Chroma is a vector database, okay, but there are plenty good ones. And it's local, so it's not online. So it indexes your data locally and then retrieves that data and passes it to the language model to get a response. So that happens at the query stage. So the RAG pipeline searches for the most relevant information on the user's query. And this information is then given to the language model along with the query to create a more accurate response. Okay, so this process allows the language model to have access to the current updated information that may not have been included in this initial training. And you guys haven't seen it yet. All right. So the main challenge during this stage, go back. So the main challenge, forward. The main challenge during this stage is retrieving, organizing, and reasoning over potentially multiple knowledge sources. So that is where there might be a challenge if the sources gets too much. This is all just came out in the last 6 months. RAG is February or March. All right, next. Okay, so this is how to install it. Okay, so you keep installing. There are updates. Okay, I didn't follow the latest update. So the previous version, before version 8, you have to set up your OpenAI key because it defaults to the language model. But now it defaults to a Hugging Face, one of the Hugging Face language models. So you can do it. That I think from version 8, you don't need the OpenAI key. Now, in fact, they default to a free language model, so you can use it without keys. So once you've inserted your key, just make sure that you install the OpenAI. Next page. Yeah, then, okay, so I wanted to do a demo for, download your resume from LinkedIn. And then, make sure you install the PyPDF so that you put it in a directory. So when you've done this thing, right, you start, your first statement is import the 3 index single directory. So we're going to use an index tree. There are other index type, but that's not what you're doing. My bootcamp is not deep enough going to that level. So let's find it. So the directory reader reads the document from the directory server. So where your code is, creates a folder, private data, and put your resume there. LinkedIn resume, right? But it could be any other resume. It doesn't matter. It's just for us to ask a simple question. So once data has been indexed, you can begin asking questions to it. So you set up the query engine like this, and then you ask, when did Emeka graduated, whoever owns the resume, whoever's name is in that resume, then you get a response. This is the fastest. So this one does for PDF. Quickly, you can talk with your PDF locally. It's that simple. If it's harder like this, then there's a problem. Yeah. So you can ask for that question. So the most important thing here, saving and loading. The new index, which is the index you created in the other one, just make sure it persists so that it saves that index, because the index is not saved. Then you can load it. So you set up your load index storage. This is when you save it, it saves at a folder called storage. So you now have 2 folders. So you load your storage in the storage context, and then load the index from the storage context, and then you ask the question again. So because indexing takes a lot of time, you understand? So you don't want to go over that process. Okay, and then you can ask the question. It's not hard. If you can't get this one, I don't want to see you guys in my class. All right. Okay, next. Okay, so this is basically to describe the setup, the LLMs here, your knowledge base, which could be anything, knowledge graph, PDFs, data from the office, we generate relevant context, and then it uses it again. So these are agent tools, which you can use to get information from. And instead of data loaders, next one. Yeah, data loaders, where you can pick data from. And you can create these tools yourself. So because this is a new technology, so you just start it. You can create your own. Next one. So yeah, Llama Index provides a complete toolkit language-based application. On top of that, you can use various data loaders and inject tools from the Llama hub to develop complex applications with multiple functionalities. You can connect custom data sources to your LLM with one or more data loaders. You can also use agent tools to integrate third parties and API. Okay? So you can use it to build also. So what you've just done is a question and answer over documents. That's just what I did. But you can do a chatbot, the chatbots, the changes are not much. Yeah. Then you can do an agent thing. Structured data full stack web application. There's so much you can do with it. It almost has the same pattern with LangChain. Okay, I didn't delve into this much, but you guys can always check for it. Next page. Yeah, so always install with the OR, because there are so many dependencies for the LangChain. Okay. Yeah, then we have council too. The same council integrates to LangChain and Llama Index. as well. But it's more, council is more toward agents, developing agents tool. You know, they are chain ML, they are based in Canada. Yeah, next. Yeah, so this is features from the council framework. Okay. And this is the historic council. Okay, so conclusion. You guys didn't see what? Yes. Training, yeah, but they are not selling it well. All right, they are engineers, but they are still. Wait. Retrieve training. There's a word, there's a word I'm expecting. Not for it. The run is an alternative to fine tuning. If you don't fine tune, you can as well do that. That's how you get the latest updates. So the LLM can be LLM of 1965. And then, you know, you use your own data sources. In this way, if you don't understand the ask question now, because this conclusion now is one way road, because there's no way back. If you don't ask question now, that's the RAG is an alternative to fine tuning. And it becomes more interesting if you can do your language model offline. Yes, if you can do it offline, it's sweeter, but I know, you know, database infrastructure, infrastructure might be a challenge. But if you have your language model offline in an organization, now, I'm not talking from an individual point now, from an organizational point, it's the best, like Llama 2, you know, you can do Llama 2 offline and then run RAG. Then they are not interested in updating Llama 2. They are more interested in your data coming from your knowledge graphs and all that. Do you understand? The thing is that fine tuning means that you have to keep updating, you know, updates, yeah. But this one, you can just keep it, you know, we don't know how, as data is growing, how it will be if your data is growing very fast. Your local data is growing very fast. We can't say that much. This is a 6 month period, so we don't know whether when it grows up, it will have 4 eyes or it's going to be 2 eyes. We don't know yet. When we get to that point, we will know. But these are things that, you know, we will keep figuring out as we are now. So RAG is a good alternative to function. Okay? So we've gotten a lot of things from me today. Okay, let's close up. Okay, so basically, this concept complements each other. So everything that we've said here, the thing I need you guys to understand is that AI system is a combination of knowledge representation, machine learning. That's all I need us all. I think we need from there. Okay, everybody's going to play their role. Okay, so answering open domain questions requires world knowledge. I haven't even talked about what they call the linked open data. The linked open data, there's a massive data set outside Wikipedia that exists. If I could do a lecture on how knowledge graphs were used during COVID. So we have what's it called? Proto. Proto is like the biggest database. It's a knowledge graph in the world. So 5 bits, you know. So everything about proteins. The biological space they are more advanced. Bioinformatics, they all use knowledge. You can't operate in that space without knowledge. Yeah. So, as pre-trained language models like the power to store required knowledge, external knowledge sources such as knowledge graphs are used to augment. Okay, two knowledge sources have complementary strengths. They complement each other. Okay, I think we have to emphasize that. So, language models and knowledge graph represents significant advancements in search technology, offering more accurate, relevant results for users. Next. So we can use it to develop all these kind of applications, which, recommendation system, Q&As, search engines, virtual assistants. They are going to be, this article is going to be shared to everyone, right? On the last note, this is what a friend of mine said, which I found. He said this yesterday. I found it very fascinating. So there are new concepts. We have what we call the personal knowledge graph. So the personal knowledge graph is going to be huge, going to be very big in the future. So it's a knowledge graph of the things you like, the things you want to buy, the things about you. Because we're going to have, I mentioned digital twins. We're going to have digital twins who will be running errands on their behalf. Okay, it's not far-fetched. It's about to start. So we have that's some ports. So ports are your thing. This is where your privacy. So these are my data. If you want my data, so you're in control of your data. So this is happening in the knowledge representation side. Okay. Then we have things like the smart agents, which are your digital twins. So in 2008 language model, unlocking a realm of further possibilities. So these things will open a whole lot of stuff, in this space, as we have already seen within 6 months. We've already seen how things are. So thank you, everybody.
If we go about this, Mr. Emeka, you can pick it up. Thank you very much, Mr. Emeka. So we appreciate you for that wonderful and lovely session. So on behalf of the management staff and advisory board of DSN, wants to thank you. Can a participant online also celebrate Mr. Emeka? Is there celebrating on site and online? Thank you very much. So shortly we're going to be going to the next session. However, I don't know if we have any questions. If we have questions for Mr. Emeka. Yeah, you do. Okay, so we'll take your question. Give back to you. So who else has another question aside so that we can take all the questions maybe all together? So just one. Okay, 2, 3, well, so 4, 5. So please remember your question. So 5 is enough. Briefly, 1.
Your session was really impactful and I really enjoyed it. So my question is on the basis of ethics and AI. So we know that knowledge graph, we are teaching the machines what to do. How do we call bias and how do we reduce that? So that's what my question is.
Okay, so
all right, so very, very good question, because this is a very big problem. So, I talk about us downloading, we just go and download data sets that we don't know where. There are no guards against what it comes with. So the strongest thing about knowledge representation is that it has logic, rules. So we can make our real world view as part of our data. So your data comes with those rules like, don't do this, do this. If this is this, then this should be this. Do this. Those rules are very important because you can use it to prevent fake news. You can use it to prevent prejudice, bias. If any of that are following you will notice that even in the situations where there were issues in Google, that whole Google thing, I kept talking about, using knowledge representation as a way to set rules against certain things, that happen. So the good thing about it is that you can put those real world rules, because they are bad actors, biases, but how do you prevent that? Okay, so that's the safeguard that we have, is that knowledge representation has those features that we can use to reduce, I won't say prevent, that will reduce the effects of bias and unethical issue. Rules matter. You can't just collect data like that. Yeah, we have to, first of all, we don't understand how the data is aligned. Okay, whether it's it's against women or it's focused on a certain opinion. So when you have those issues, you can create rules to create a balance in your society. That's why I am pro regulation for AI. We need regulation, because the data, this is not computing, this is not data, this is society. Once this algorithm start working, it affects the society. So we need our societal guardrails to be part of this one.
Thank you very much. A round of applause for him. I think I'll just repeat something. That will speak to one of the workshops we had recently. I don't know if anyone actually participated. Microsoft Responsible AI Dashboard, right? So it's a tool that helps you to check fairness, bias, and try to call non-accountability. So you can also check that out. We have it's part of what we actually put together as part of this intervention. So question number 2. Are you number 2? Yes, okay, I'll come back to you. Number 2. Someone picks number 2, I think. Richard. Were you number 2?
Yeah, thank you very much, sir, for the valuable information. It was very, very educating. We really, really appreciate it. Before 2023, it's hardly I see anything about LLM and generative AI, but now it's everywhere. It's very hot. So I want to know why it's hot like that and why it's endearing to a lot of experts. And secondly, the personal knowledge that we talk about, is there any possibility of something like community knowledge graph or something like that? Thank you.
Thank you very much.
Okay, so one of the reasons language models are hot is because it takes over. Let me tell you how the world works. When you find an easier way to do things, the older way fizzles out. Okay, so language model comes in, and one of the first things that we could easily do is that it will help us write programs. So for coders, it was easy and it's simple, because when you have Stack Overflow data in it, you're just telling it to produce all Stack Overflow algorithms, and you can use that to create it. So code was so easy for it to reuse that word, because data reuse is one of the most powerful things about data. So we could reuse it in so many ways that makes us more efficient. So we don't need to think through all that. So it becomes popular. It helps you summarize. It helps you generate ideas. So these ideas are actually hallucination, but hallucination that has value. You understand? It will hallucinate, and it might make sense to you, or it can make you look stupid. So it does a lot of things that takes time from us. you find that there's so much use for it. Okay, you can use it to check things. For instance, my best AI country in the world today is UAE, Arab Emirates. They just came out with Falcon language model, and in that Falcon language model, the embedded one of the data used to train has something to do with business registration. So they are making it easy, and also for their laws are there. So what does that tell you? It means that you can use the language model to ask questions on basic legal stuff, and also things that will help you to register your business and help you to register your tax. Okay, so you don't need to start, looking for people who are experts in this thing. The language model can do that. So you can build language model for a particular domain, and it helps you with the question and answering. You can, easily do things that you could have ordinarily driven a car to, have a meeting, appointment, and all that. So it helps us, make it easier for us. Yeah. Okay. And for what he has, is doing quite a lot. But it's also working out with routine work. You see those work that you don't need to think. He's removing them, which is not a bad thing, but unfortunately, our client have not been producing high skill work. That's where the problem is. Now we now have less use of the secretary. We can now say, oh, please write me a letter that I need to send to MTN for them to change my line. Why do I need to employ somebody to do that? That's a prompt. And that prompt, I'll share it with everybody in the office, and everybody will be using that prompt. That's so many secretaries' job that they have removed. So, you'll find out that a lot of work that has to do with, creating text can be taken over by language models. All right. Then your second question was knowledge graph. Yeah, knowledge graph can be used for everything, including water, pure water. It's a domain, it's a topic, any topic you can create a knowledge graph so that it creates, the relationships in the terms in that it helps you to understand that topic very well. That's the thing about knowledge graph. I mentioned about the top cities in the world, they use knowledge graph to manage their city. So to make sure you have light, you have water and all that. They know your problems. They know that if somebody 2 feet away has COVID, there's a chance that they're going to have COVID. They will evacuate you. They don't need to evacuate and all that. So this is just like I talked about that pipe, connection. They see those kind of connections and make decisions about it. So these are the things that, you'll find out that what I've just told you on knowledge representation is high level data management. Data management that is very smart, okay? That you can put in so much for it to yield you so much insight and all that. So these are very powerful tools that are supposed to help us live a better life.
Thank you very much. I hope your question is answered. Third question, I think it's you, right? Or can we? Okay.
Good afternoon, sir. We're enjoying this session. So my question is, we've seen that language model struggle with reasoning and mathematics. So knowledge graph help with that problem, but most of the choices you don't put them out there, actual data on that. We know that our reasoning, the mathematical reasoning and mathematical questions.
Actually, the strength of knowledge graph is reasoning. So thematic reasoning, inference reasoning, deductive reasoning, and what's the other one? Yes, so those are this. When it comes to reasoning, semantic technology is your uncle. Yeah, so we can reason with, it will give you all that. and you don't get so much of that. So that's why we need to fine tune or rag, from the knowledge graph, with their rag, we bring context. And that context usually comes from BC. So it will help the outreach for language. It's key that we understand. You don't need to be an expert. If you're on the machine learning side, you don't have to be an expert in knowledge representation, but you need to have an understanding so that you don't work in silos. You understand? So if there's need for you to work with knowledge engineers, you work with knowledge engineers, but have an understanding. AI, machine learning is not AI. You understand? There is the other side. You'll find out that if you look at the semantic side, there's so much, reasoning, inference, not the same inference we have in machine learning. What's it called? Logic and provenance. Semantic has lots of features for provenance. So sort of data has to be tracked. Where did it come from? Who did it? What kind of person is it? You see, everything is about relationship. So that's why it's very powerful. We make the best from this.
Thank you, sir. I think we're almost getting to the end of it. Number 4. So he's told me what but number 4. Okay, so I think I'll just take this. So there's a question. Good morning, Mr. Emeka. I want to ask, is there any data about tomato in Nigeria? Studied agriculture in my first degree. I know the constraint to be with producing and transporting tomato, but what I know is that is what I have experienced. There's no whole open data graph. There's no whole open data to this. So is there a data? That's just the question.
Okay, so let me talk more on this so that we all have an idea. So the answer is simply zero. The government, every same economy or society in the world take data very serious. So if you look at the composition of government, you see a lot of data professionals. And if you see the structure of government, you find that government is structurally linked to academia. So you see a lot of professors, researchers, researchers and government should be government. You know why? Because the source of knowledge in societies come from researchers, science researchers, academia. That's what academia is for. Knowledge creation. So if government that is ruling the society is not interested in acquiring new knowledge, then there's a problem. And this researchers also need data from industry, data from government, what they are seeing. It is curiosity of government that creates a lot of government paid research. So if government is interested in solving the tomato problem, they have to bring context based on the information that they've seen where these tomatoes are being produced, and ask our researchers to think of a way where these tomatoes to Lagos market takes 5 days. Is there any way we can preserve it for 5 days? What's the best way? So once that data is out there, researchers will create new data to augment that data. Then data professionals can work on that data and bring up temporary solution. Data is infrastructure, but we don't understand that. The system doesn't understand. So when we have that data as infrastructure, the data we can give in hands, and everybody can give that data. This is what happens in every single country in the world, except nowhere. So the point is, until we get it, it doesn't matter if I know how to solve the tomato problem, because I don't have the power to solve the tomato problem. So it's not only that I know how to solve it by data, but I also have to know how to solve it with governance from the system level. Okay? So the challenge that we have, is that we don't have a country that takes data seriously. So I need also to all understand this, because that's the thing that is holding us down. That's why there are plenty data jobs locally. Let's not be fooled. That's why I say people should join the global app and go and find that data war.
Thank you very much. Can we give it up for Mr. Emeka? Thank you very, very much. I think the question online, is that what you want to ask? That's what I want to ask. So, are you the one that asked the question? Okay, so someone asked online. I actually thought that should be like a closing question, sort of. So the person is asking, you can sit down, sir. So he's asking for the link. Someone is asking for the link to the unpaid internship. So like, what's the point? You can see that it's actually not the question. Just
So, okay, so that's it. Let me- So, on your page internship, okay, this is the thing. This is how it works for everybody at advice. So there are organizations you want to work with. Unfortunately, these advice are only work mostly abroad. Because not that it failed here. The problem is, you want to work where there's a lot of data. Right. So you work up, you make some preliminary findings on what industry challenges, the economic sector challenges are, and then how you can be of help or how you can help them. So maybe a competitor that has a problem and you take for granted that you may be having that problem, which is not a problem because all they want to see is your thought process. So you use that, prepare a plan on how you want to solve the problem, and then take that, and walk up, to the organization and tell them that they are looking for internship. In fact, if you research further, you could find out the people at the departments that you are really interested in, and then go to them. So a lot of them taking free interns. Some people might not, some organizations might not take, but you just take them. Right. So here in Nigeria, we could do that. But my advice is don't go and visit my mechanic and say you want to do free interns data. You'll be coming spam and free with no knowledge. So it has to be a place where you're sure that there's data or data related thing. And other than outside the likes of MTN, Airtel, and some very few companies are not having one. So let's be sure at least they have data, they take data seriously. That's what you want. But if not, if you're outside the country, have a plan and then walk up to a company. But usually go for the big companies. They do appreciate this. But they want to put some effort. You can't just, walk up to somewhere like Netflix and say, well, I want to do free internship. Maybe your own plans that way.
thank you very much. I will appreciate someone again. So, in summary, to address the question, try and get the specific problems right. Then you can probably try and drive out a possible implementation by going for an internship, right? So let's appreciate Mr. Emeka one. Let's appreciate Mr. Emeka. So officially we're just going to we're on break. Right, let me start. We're on break. So